Let's start with those images from Namibia. During the lunar eclipse in August 2024, photographers took advantage of Earth's shadow blocking the moon, creating the darkest possible sky. Perfect conditions for deep space observation. They aimed their equipment at 3I Atlas as it moved between Mars and Jupiter. What they captured stopped scientists cold. The object was radiating bright green light across the darkness. Vivid, unmistakable, impossible. Now, you see, green comets aren't actually that unusual. We've seen it happen before. The science is pretty straightforward. When comets get close to the sun, ultraviolet radiation breaks down carbon molecules in the gas cloud surrounding them. That's called the coma. Specifically, it affects diatomic carbon, or C2, which is just two carbon atoms bonded together. When C2 gets hit with sunlight, it emits green light. It's basic chemistry. Predictable. Well understood. Every green comet we've ever studied has followed this exact process. Here's where things get strange. Multiple telescopes observed 3I Atlas over the summer. We're talking about every major observatory on the planet pointing instruments at this thing. They analyzed its composition, ran the spectroscopy, checked for those carbon chain molecules. The results? 3I Atlas is deficient in C2. It doesn't have the chemistry that creates green light. The carbon simply isn't there in the right form. And yet the photographs don't lie. It's glowing green anyway. Bright green. The kind of green that should only happen when C2 molecules are breaking down under solar radiation. So why is it happening? We don't know. There's no natural explanation in our current understanding of comet chemistry. Some scientists have suggested maybe there's a different process we haven't discovered yet. Maybe. But that still doesn't explain what we're seeing. The object is doing something it has no chemical right to do. And the green glow? That's just the beginning of what makes 3I Atlas so unusual. But that's not all. When scientists analyzed the coma surrounding 3I Atlas, they found something else that doesn't add up. The gas cloud is absolutely loaded with carbon dioxide, CO2. Now, comets do release CO2 when they heat up. That's normal. What's not normal is the ratio. See, typical comets are mostly water vapor with some CO2 mixed in. Think of it like 80% water, 20% carbon dioxide. 3I Atlas flips that completely backwards. It's releasing vastly more CO2 than H2O. The exact opposite of what a comet should be doing. Why? No clear answer. And here's another strange thing. The coma is also full of nickel, metal vapor, floating in space around this object. Again, metal in comets isn't unheard of. But here's the problem. Metal only vaporizes when a comet gets incredibly close to the sun. We're talking scorching heat that literally boils metal off the surface. 3I Atlas was out between Mars and Jupiter when telescopes first detected the nickel. That's nowhere near hot enough. There's no reasonable explanation for why it's releasing metal vapor at that distance. Unless something else is generating heat or releasing exhaust. Of course, there's probably a natural explanation for the metal vapor. We just don't know what it is yet. But there's something else happening with 3I Atlas that might be even stranger. Something about the way it's moving through space. Here's how comets normally behave. As they heat up approaching the sun, their surface ice turns directly into gas. That's called sublimation. And when that gas bursts out, it acts like a thruster, pushing the comet around. Sometimes it speeds up. Sometimes it changes direction slightly. Scientists call this non-gravitational acceleration, or NGA for short. Basically, it's movement that doesn't come from gravity alone. We measure it by tracking how much a comet's position shifts per day on average. Every comet does this. It's constant, chaotic movement as different sides heat up and release gas. Except 3I Atlas barely moves at all. Let me put this in perspective. Since May, 3I Atlas has fluctuated by only about 1.5 kilometers of NGA per day. That's incredibly stable. Now compare that with 2I Borisov, the most normal interstellar comet we've ever seen. Borisov was moving around by over 100 kilometers per day. That's about 100 times more variation than Atlas. What about Hale-Bopp, one of the biggest comets ever discovered? At least as massive as 3I Atlas. It averaged over 10 kilometers of daily movement. 10 times more than Atlas. And Oumuamua, the first interstellar visitor, over 1,000 kilometers per day at some points. So even compared to other objects from beyond our solar system, 3I Atlas is holding an unusually steady course. Almost too steady. You could say it's moving with precision, like it's being guided toward a specific destination. Now, that's probably just a coincidence. Probably. But if it were being steered, what would that mean for where it's headed? Here's a theory that sounds crazy until you hear all the details. There might be a connection between 3I Atlas and one of the most famous unexplained signals ever detected from space. August 15, 1977, Ohio State University. Astronomers were using the Big Ear radio telescope to scan deep space when they detected something that shouldn't exist. A narrow-band radio signal, incredibly powerful, lasting exactly 72 seconds. It came from somewhere in the constellation Sagittarius. The astronomer reviewing the data was so shocked, he wrote "wow" on the printout. That's still what we call it. The wee-wow signal. What made it so strange was the frequency, 1420 megahertz. That's the hydrogen line, the exact frequency that hydrogen atoms naturally emit. If you wanted to send a message that any scientifically advanced civilization would recognize, that's the frequency you'd choose. We've been listening ever since. Nothing. The wow signal never repeated. Now, here's where it gets interesting. Astronomers have traced 3I Atlas backwards through space, calculating where it came from. The direction? Sagittarius. The same region as the wow signal. And here's the thing. In 1977, 3I Atlas would have been on the outer edge of our solar system, somewhere beyond Pluto's orbit. Still approaching. Maybe the signal wasn't from some distant star. Maybe it came from our visitor. A heads up that something was on its way. That's a pretty big coincidence. Of course, that's just speculation. There's no proof connecting these two events, but there's also no proof they're unrelated. And right now, as 3I Atlas moves deeper into our solar system, we can't rule anything out. Scientists are tracking 3I Atlas closely as it passes through the inner solar system. In the coming months, it'll swing around the sun and head back out into deep space. We'll be watching its path, analyzing every signal, every movement. The question we can't answer yet, is it just passing through, or was this always the destination?